Welcome to Research Creations. In this video, we will go through Newton's fundamental laws of motion. This is a basis for kinematics and dynamics since it allows us to define how objects interact with forces. There are three laws that we have to grasp. The first defines the properties of objects in states of motion, being inertia. The second is force, involving a critical formula. And the third law is action and reaction. Let's start by talking about the first law of motion, inertia. Let's say that you're driving a car, and you firmly press down on the brake pedal. You'll notice that your body lunges towards the steering wheel as you come to a stop. Not only is this a crime, but it is also an example of Newton's first law of motion in action as well. We first have to understand what is meant by a resultant force. A resultant force, you could say, is the force left over when there are multiple forces applied to an object. For example, there could be two equal and opposite forces. In this case, there would be zero resultant force, as both forces will cancel each other out. Or we could take this example, when there are two unequal and opposite forces. The object would then be affected by a magnitude that is the difference between both forces, in the direction of the greater force, as you can see here. A general rule of thumb is to understand that forces are vector quantities, meaning that magnitude and, more importantly, direction exist. Therefore, forces can exist as negative values, and in its simplest form, you can just add those force values together to obtain the resultant force. Newton's first law of motion states that an object will remain at rest or in linear motion unless an external resultant force compels it to change its state of motion. This suggests that if the resultant force on an object is zero, an object at rest will remain stationary, and an object in motion will continue to travel at a constant velocity in a straight line. We now know that objects tend to resist changes in their state of motion. But how can we quantify this resistance? This property, which we call inertia, is the resistance against change in an object's velocity and is defined by an object's inertial mass. This is mathematically derived as the resultant force divided by the object's acceleration, which is a formula from the second law of motion. This means that an object with a large mass requires an equally proportional larger force to change its velocity. This ties in to our example from earlier. When the car rapidly slows down, the car loses its velocity. Due to inertia, your body, which has a considerable mass relative to the car, stays in motion. It is this motion that lunges you forward before the seatbelt catches you. Now let's move on to Newton's second law of motion. Let's picture another example. When you floor the accelerator of our car of science, you start to accelerate. Why does this happen? What does the amount of force your car exerts have anything to do with its change in speed? Newton's second law of motion states that when an external non-zero resultant force acts on an object, it will accelerate in the direction of that force. For example, if a resultant force acts on a stationary object, it will accelerate and begin to move. Or when the force acts in the same direction as the object's motion, it will accelerate and speed up. When a resultant force acts opposite to the direction of motion, it will cause the object to decelerate and come to a stop. How about if a force changes the direction of an object's motion? That would change the object's velocity, as velocity is a vector determined by speed and direction. Since acceleration is a change in velocity over a change in time, a change in direction would also change our acceleration. Going back to our example, we now know that the force exerted by the car on itself allows it to accelerate. We can quantify this mathematically, as the second law also states that the magnitude of the resultant force is directly proportional to the acceleration caused by the force. This means that a change in the resultant force will lead to an equal change in acceleration. This is constituted by the formula F equals ma. the resultant force being equal to mass multiplied by acceleration. For example, if an object accelerates at 5 meters per second squared to the right and has a mass of 2 kilograms, we can use this formula to find the resultant force, being 2 multiplied by 5, 10 newtons. Let's test what we know so far with a practice problem. Let's suppose we have a cube traveling on a non-frictionless surface. 8 newtons of force is pushing the cube to the right, while friction of 3 newtons resists the 8 newton force. If the cube has a mass of 2 kilograms, what is the acceleration experienced by the cube? Our first step is to find the resultant force. We have a forward force of positive 8 newtons and an opposing frictional force of negative 3 newtons. Therefore, our resultant force would be 5 newtons to the right. Using the formula F equals ma, we know that acceleration equals force over mass. Therefore, the acceleration experienced by the cube would be 2.5 meters per second squared to the right. Now moving on to our third and final law, action and reaction. How are rockets able to propel themselves? Well, Newton's third law of motion has some of the answers. The third law of motion states that when two objects interact with one another, every action due to a force will encounter an equal and opposite reaction. For example, if you push on a wall with a force of 50 newtons, you would experience pressure on your hands worth 50 newtons of force in the opposite direction. The force in this example has a name, and it is called the normal contact force. Let's take our example from earlier. A rocket can propel itself upwards because its engines release hot gases traveling at high velocities out the bottom of its nozzle. Due to the third law of motion, an upwards force, thrust, is produced opposite to the engine force, propelling the rocket upwards. That is how launches like this are made possible. Let's go over everything we have covered in this video. The resultant force is the force left over from multiple forces acting on an object. The first law of motion, inertia, is defined as an object's tendency to retain its state of motion, where an object will stay at rest or in linear motion unless an external force compels it to change its state of motion. The second law states that a non-zero resultant force will cause an object to accelerate, and that the resultant force is directly proportional to the acceleration caused by it. The third and final law conditions all actions due to a force acting on an object will have an equal and opposite reaction. Thank you for watching.